Michael is Vince. We're the founders of a new company called Scaphold.io. We're actually currently going through Combinator, and this was a perfect lead up because we're building a GraphQL backend-as-a-service that is also real time. So you can do all of this stuff that was just talked about on our platform. But we're going to start at the high level of GraphQL, show you a little quick demo, and we're going to get you guys out of here quick. So, all right. Build better apps with GraphQL. So Vince and I were app developers in college together. We went on to work at Microsoft, and then about a year ago, we saw this chart. So that's the Google Trends for GraphQL. And we were like, what the heck is going on? What is this thing? Let's figure out what it is. So then we went and started building some stuff, and we realized that from the client's perspective, GraphQL is so far and away better than REST. And in 5 years, people aren't going to be building REST APIs anymore. It's all going to be GraphQL. I'm calling it. So then, yeah, I'm calling it. But we found that building GraphQL systems, building server-side code that implement the GraphQL protocol is still a big pain. You need to worry about databases. You're worrying for real time. You're thinking I'm running Redis. You're running different databases, different web service, scalability. All these things are still tough. So we figured, OK, who's using GraphQL? All these big guys. It came out of Facebook. That makes sense. We've talked to a number of YC companies that are building on GraphQL. Intuit's using it. Twitter's using it. GitHub's using it. New York Times are using it. Credit Karma's using it. All these companies are moving to GraphQL because it's better. So we thought, OK, goodbye REST. It's dead. It's OK, though, because GraphQL is better. So then, why is it better? GraphQL is an open standard. It's easier to learn, it's easier to maintain, it's easy to document. You can kind of dig through the schema itself and kind of figure out what's going on. And it's just way easier to consume from client applications. You can also build better client tooling. So you're going to see better dev tools being built. Like Apollo is leading a lot of awesome developer work that's tying in the GraphQL type system with like your Swift type system at compile time. So you're not going to have nulls in your queries through the web, like over the wire to servers. It's crazy. So another reason, GraphQL is a type system. If you guys have built apps on REST APIs before, it's a huge pain. Not only do you have this endpoint hell, you're worrying about, like if you're hitting SoundCloud, you're hitting /track67, you're going to get some amorphous blob back, and you have no idea what it is. GraphQL changes it. They put a type system. So you have, I have type user, I have type log, I have type post. That makes sense. I'm building a blog, right? The next thing, an intuitive query language. So you get this really nice the synergy between what you ask for and what you get. So on the left is a query. I want the user with some long ID. And on the result, you're going to get exactly those fields in the user. There's other data in that user model. I'm just not asking for it because my front-end application doesn't need it. So you're getting more efficient transfers over the wire, and it's much more clear from the client perspective. The next reason, it's perfect for modern front-end development. Everyone loves React, right? I mean, even Angular 2, everything's moving towards this component model. You have these beautiful, these hierarchies of components in your front-end application. And if you look at, I've got a user component. My user component's going to display the posts of my user. The query, you get a user, and then you get this hierarchical data that shows the exact representation of what you need to show in your front end. So it's really nice from that perspective. And we're going to go in. So we're a backend-as-a-service. We allow you to build these systems really quickly. And I built Slack in like 15 minutes the other day. I had the front end, but OK, so we're going to kind of dig through, and we're going to show you a little demo. So this was perfect before because there's going to be some overlap. So I'm going to start with like a really low level or kind of easy implementation of a GraphQL server. So let's bring this up. I'll blow it up for you guys.
There you go.
All right. So we have 3 files. This is our entire application. So on the left, you're going to see a simple Express server. Apollo is a tool chain that's being built by. Is it still too small? Okay. So
Is that better?
Apollo is a tool chain that's being built by the guys over at Meteor that we work with, and they're doing some really awesome stuff. So they have some kind of helpers. There's also great packages maintained by Facebook. Express GraphQL is one. GraphQL.js is another. And what you can see is, OK, it's a simple server. So I'm saying I'm attaching this Apollo server, just think GraphQL server, to this endpoint called GraphQL. So what is that doing? So that's pulling in a schema. So then that's this file. So I'm actually writing my schema in the GraphQL schema language. So in the Jacobo's presentation, he had kind of like that long form representation where it was like written in JavaScript and it was actual code. A lot of the new tooling allows you to actually write it in the schema language, which is really nice because it's much more concise. So I see, OK, so we're building Slack. Remember that. So
we're building Slack. Slack has channels. Channels have messages. So we've got the type query. It has channels and messages. The channel has a list of messages, and the message points back to a channel via channel ID. So, and then for simple sake, I'm keeping an in-memory database, right? So in this example, I basically have 3 messages. I have 3 channels. And then if you look at the mocks, you'll see that the blank channels query returns the full list of channels, this guy. The blank messages query returns the full list of messages, this guy. And then, but you can even dig down further. So if you look at our channel type, the channel type has an ID, a name, and messages. So what this allows you to do, we call these resolvers. So these are mock resolvers. But when you're implementing GraphQL systems, you implement resolvers. And essentially, your type has a series of resolvers that resolve the fields on that type. That's how like the hierarchical data nesting goes on. Each type knows how to fetch all of its children data, all its child data. So if you look at this, query understands how to fetch its child data, which is channels and messages, which map up right here. And then the channel type knows how to fetch its child, which is this messages data, which actually doesn't live in the channel, but lives in its separate messages. So then this one's doing a simple filter, forgive my use of Lodash, but then it's doing a simple filter on the messages, matching the channel ID to the parent, right? Does that make sense? So then the parent, this is how in resolvers you actually have access to a parent object. So if you think about your data as a tree, you know, every field has a parent object, and then you also can pass useful information around in your resolvers, like a context that kind of lets you like keep track of different data sources, and you even can like dig into the info. So this is where the better data, like the better tooling comes, is that you have access to, when I issue that query, so I'll just show you actually. I have it running. What is it? This guy. Is it here? So it's the same kind of thing. So here's graphical again. I'm gonna blow it up. Here's a really simple query. I click run, and it returns that, but then I can dig into it further and get the messages. You get autocomplete, which is another nice thing. So imagine this is, if you were using this in REST, you'd be using something like Postman, and then you'd be making a request to channels, you'd get back a list of message IDs, and then you'd go make 5 more requests to get the messages. So this is just like that just gives an idea of how much easier this is. I get autocomplete, all these nice things, I run it again, and now my data changes, right? So then this all worked just because those mock resolvers are pulling from that static database. Well, you know, static object. But cool. All right. So that's kind of like the gist, right? So we're kind of selling that this GraphQL thing is a much better way to build apps, and you can do it really fast too. Like it makes more sense. You get a type system. Imagine like the difference between writing in something like, I don't know, like adding types. Like there's a reason that people keep adding types to JavaScript, right? Like Flow and TypeScript. It like adds a lot of like reason and understanding to your code. And you can do the same thing at the data layer. So then now we're going to show you how to do something a little bit more interesting. So this is like a really easy way to get started. You know, Node has awesome instrumentation. There's a lot of great tools out there to build GraphQL systems, but it still takes a lot of time. So we're going to show you how we built this. So this is our Slacker tutorial. So it's like Slack, but worse. So, I think I lost the other window. Let me just open a new one. So this is, so before we were mentioning that there's no official implementation of subscriptions, which is true, but there are really good kind of solutions out there, and we're actually working with the Apollo guys to finally get one set in stone. So we use our service, we host, we basically give you, scalable servers and databases and all these things in a couple of seconds, and you can define your data model, get your schema up, and then you have a GraphQL API that you can manipulate and change, and it's all on the fly, and you can launch a bunch of apps. And then we actually we provide subscriptions as a part of that service, and we use this new kind of protocol that was developed by the Apollo guys, and we're trying to get it officially accepted. So I'll just go ahead and create a new channel. I'll show, I pull up 2 windows for a reason. Because you'll see on the right, when I create this, it appeared right there on the right. So then I can join that channel. Uh-oh. I think this one on the left lost its socket connection. Let's pull that again. I'll join. Here we go. And then you can start typing. And then they appear at the same time. So that socket's going. Cool. All right, so this is Slacker. So this is, we had this all set up for you, but then we're going to show you how easy it was that we actually set it up. And I'm going to pass it off to Vince, and he's going to show you what we've built.
Oh, cool. Thanks, Michael. Yeah, so Michael basically walked you through how to set up a GraphQL server, basically like from scratch. You can find all that code on our GitHub. We have many more as well. But for those of you who want to just feel the benefits of GraphQL, want to start playing around with it before having to dive into too much GraphQL speak, we built this awesome platform, just for ourselves initially as app developers to be able to spin up apps really quickly using this cool new technology. And so, the type system for GraphQL, we kind of represent it as this, schema designer. So you can see all of your types here, and essentially, here, Alex, you want me to blow it up? Ooh, better? Okay, cool. So basically, like, all of your types in your schema are represented in this very nice UI that allows you to like define descriptions, fields, and like every time you create a type, what we do, I won't do it here, we have enough. But basically, every time you create a type, we spin up new tables in your database. We migrate your schema, manage your indexes, everything that goes on behind the scenes that you probably don't want to do. You just want to build your app. For all intents and purposes, Michael created a bunch of messages, so this would be the model for a message. It has like ID, and every field has types as well. So ID has, it's a type ID, and each node implemented type has like created at, modified at fields, so you don't have to manage that yourself. Author for relations, and this one says user, and user is a type in our system as well. So what that signifies is a connection. So connections are essentially your way of defining relationships within your data model. That's just GraphQL speak for you, but essentially it's just connections. And then it allows you to query things in this nested way where you can continuously do what is essentially like a join on your data model in the back and then spit it on your client in one request instead of having to make round-trip requests to go fetch data every single time. And so that's your schema designer. And without having to manually write the verbose types, you get to just click around and everything just works magically. And as part of the service, like many apps, we've developed many apps, music apps, all sorts of different apps, and you don't just need your type schema, you also need other APIs, real-time, for instance, custom business logic, perhaps, if you're writing some sort of, enterprise application. So, first off, we give you integration. So, we wrote a bunch of these ourselves to give you things like push notifications, Mailgun for email, Algolia for search. So, for instance, if I wanted to hook up Stripe to add payments into my platform, perhaps I'm an e-commerce platform, I can just drop in my own secret key and API keys, and automatically I'll just add a few random keys. And what will happen is my schema will automatically, this is basically like, I'm jumping ahead here, but my schema will essentially update to have all of the exact APIs mapped into GraphQL from Stripe. So that's pretty cool. Basically, we just converted Stripe's REST API, their beautiful developer REST API, into GraphQL for you to use right out of the box. And then as soon as you turn it off, it'll be gone as well. So yeah, you can do that with many other services, most of which you might use already. In addition, we allow you to tie in custom logic. So for custom logic, this is the kitchen sink of all of your other application needs. So everything else is very modular. This allows you to tie in microservices that you might have hosted on AWS Lambda or like Webtask, or perhaps even your own REST endpoints, where you can call things before, after, in a synchronous or asynchronous way, and be able to tie that in with your application logic as your client needs it. Perhaps as a user signs up in the Slack example, you might want to send the user a confirmation to confirm their email, and then also send them a welcome email, and then send the guys who made that Slack channel a feed of people who just signed up. So this would be your way to do that in a custom way. So that's custom logic. We also give you a nice data explorer, so all of the different messages that were created. Basically, small disclosure, the Slack example was open to the world, so people have typed in random things. So if you see anything vulgar on here, that's not us. Basically, these are all the messages. These are all the channels, messages that exist on our Slack example. Yeah. And then you can directly like edit your values inline here without having to write GraphQL if you don't know yet how to write them. And of course, if you want to write GraphQL, you can do so here. We have a built-in way for you to do it. Thanks. And so I'll show you a little example of how we also tied in real-time functionality directly into our portal in the theme of this talk. So right now I just ran this subscription query, which basically subscribes to new messages being created, as denoted here, new messages being created. And what I'm going to do is create this message, and this message will have an input argument of, this is like a input arg here, and it's defined in this JSON object down here. So I'm just going to say, thanks, SFNode, and then run it here. So I'm going to run this guy, create message. And as you can see, this gave me the result, and then this gave me the feed of results. So I will actually create a new message with another exclamation point. And essentially, it'll create a new message in the feed. So this just gives you the immediate result. This gives you the list of results. And you can also do filterings and get creative with it as well. So like perhaps if I'm just doing like an update message, for instance, here. You got it? OK, cool, thanks. Like perhaps if you just want to do an update message, you won't actually get the result in your feed because we only ask to subscribe to the new messages. But you will get it directly in the adjacent panel on the right, not on the one that's swapped out. Cool. Yeah, so Michael will type it. Yeah, basically, this actually doesn't come with the GraphQL. GraphQL is like your IDE. Yeah, exactly. So what Michael just did was update the message that we just created, but it didn't come in my feed because it wasn't a new message, it was an update message. But we can subscribe to that as well if we really needed it. So it's very like client-driven. Your client gets what it wants. So we're kind of, also like, yeah, thanks. And then it also like allows you to do joins and things directly on your client. So you only have to make like one request instead of all these many requests just to get the data you need. And so that's pretty much what we do. We also offer a lot of analytics with your platform as well. So per app, you get things like response time, get to see inside of your API, how things work. And we have like a nice little tutorial and way to like manage your apps as well. So yeah, that's what we do. We're a GraphQL backend-as-a-service. And also one thing that's pretty important that I guess I should mention is in order to interact with the data that you just created and everything on the platform, one sec. Yeah, well, it's kind of just like, yeah, in order to manage, in order to like actually access the data, you would hit this API. So every single time you create a new app, what we do is we spin up a unique API for you, and you can open it up in any browser and you can start playing with it, here. And you can see your entire schema and everything. And so that's how you would access it in your app. You'd make like a post request and then append all of your queries as strings as the content of your payload, and send it up as a post request to this one singular standardized API in GraphQL. So that's how that's what we do is Scaffold. And back to the PowerPoint. If you want to learn more, you can check out Scaffold itself. That's Mount Rainier. You can check out Scaffold itself. We have starter kits on our GitHub for any language, whether you're building like React with Apollo, with Relay, Angular, iOS, Android, anything you want. And you can also like join our Slack as well. We're pretty much on there 24/7, which is weird. But but you can definitely talk to us there. And also, we're offering like a $50 code to you guys. Type in this code, once you create an app, and it'll apply directly to your account. Thanks for listening, guys. If you guys have any questions, happy to answer them. Yeah, go ahead.
Which authentication system do you support?
Which auth? Token auth. Oh yeah, it's all based on JWTs. Yeah, that's another thing. You can hook into Auth0 though, so like if you want social auth, like that's one of our integrations, so you can really easily add pretty much any auth provider you want, but we'll do it through Auth0, which we connect to.
You know how you handle the change of schema, but what about migrating the data? Sometimes, often, in fact, the change of the schema also requires you to massage your existing data in some way to go from the previous schema to the new schema.
Yeah, so it basically happens one step at a time. So like if you remove a field, and that data will be removed. So there's definitely work we could do to kind of make that smoother. But for the most part, it pretty much works. Like we use naming conventions that keep things consistent on our end. And then you add a field, we add a field. You delete a field, it's going to be deleted. So it's kind of like up to you to like figure out how that works because we're really not an ETL tool.
I understand, but
yeah.
let's go to the example.
Oh, sure.
Where you had name field, and now you want to go to first name, last name.
Mm-hmm.
Right.
How do you handle that gracefully?
So that would take user intervention. We're also considering coming out with like virtual fields. So if you wanted to add, if you had a full name and then you wanted to break it up, then like through our logic system, you'd be able to say first name, take the first half of this, last name, take the second half of this. And it'll grow like that. But then a lot of it would be like, we do a lot of migrations for customers, and a lot of it's just kind of simple scripting that we kind of help them through. And then you move the data first, and then you remove the old field. Yeah.
Yep.
What database do you use on the back end?
We use 3, really. The core data is in Aurora on AWS. And then we use Elasticsearch for our logging and analytics, and then we use Redis to power our real-time functionalities. Also caching.
So do you have blob storage as well?
We do have
Yeah.
blob storage.
Yeah, so-
So this is actually kind of a cool concept that we're playing with.
Right. Yeah. So we have files. Basically, you can upload files directly, and we store them on S3 just to be
So we're using
transparent.
this idea of,
Yeah.
so in GraphQL, there's this idea of interfaces, right? So it's kind of like in class, or like object-oriented programming. And we have this idea of kind of interfaces as data sources. So any type that implements Node, you can kind of think of as being backed by its own table in a SQL database. And then any type that implements blob is backed actually by a bucket in S3. And you can mix and match these things. So if you want to be able to create connections between types as well as store blobs with them, then you could implement both Node and blob. And then we have more of these guys coming out soon. But then if you don't implement any of those things, then that type will actually be stored in line. So you get a lot of flexibility with how you store your data. Like if you have, if a user has addresses and they only ever have one address, it's probably like you probably don't need to have a full table for addresses. You can just store it in line, right? So it's like kind of interesting the way that that's happening. We haven't really seen anyone else doing that.
Yeah, so files, another thing to note is we also offer a CDN as well. So everything that you store in our system, we offer to you back as a CloudFront CDN URL. So that's how it works.
Pre-signed.
Pre-signed.
All right, well, thanks, guys.
Cool, thanks.